Okay, the next method we're going to discuss is k-means clustering. Also a very useful tool for finding clusters in the data. And it works in any dimension, but in order to demonstrate it for you, I'm going to do it in 2 dimensions because we can actually look at the clusters and see how well it's done. So first what we're going to do is we're going to actually make some fake data just for purposes of demonstration. So this is a typical incantation when you make fake data. So first of all, we set the seed, the random number seed, to using some arbitrary number. 101 somehow is my arbitrary number. It comes up a lot. So I set the seed. Then I'm going to make a matrix of random normals, a 2-column matrix, and I want 100 observations. So embedded inside the call to matrix, the data comes from R norm, and I'm going to make 100 times 2 because I want 2 columns, standard normals. And then this says there's 100 columns and 100 rows and 2 columns. Okay, so I generate the data. So at this point, it's just a cloud of Gaussians. But now what I'm going to do is I'm going to make 4 clusters. So I'm going to generate some means, and I'm going to displace some of these Gaussians by shifting their means around and differently for each, for 4 clusters. So the way I do that, I make another random normal matrix. In this case, I want 8 because there's going to be 4 clusters, each with 2 means. Okay, so I'm generating the means here. And here the random normals have standard deviation 4 because I want these means to be shift around much more than the actual data did. And so it's going to be a 4-column matrix of means and, 4 rows and 2 columns. Okay, so that's how I get the means. And now I decide which of the rows get which means. So I'm going to pick a random sample from the numbers 1 to 4. I want 100 of them because I've got 100 rows, and replace equals true. So which is going to say which observation belongs to which cluster. So now I simply add the appropriate mean to the appropriate rows. So this is a kind of typical R vector operation that's nice and tricky and effective. So X mean is a 4-row matrix, but I'm indexing it with 100 indices. So that'll produce a 100-row matrix with 2 columns, right? So it'll pick out the right mean for each row. And I just add it to the original X. Okay, and now I make a plot, and there you have it. So there's a plot X, so it plots the first 2 coordinates, there only are 2 coordinates, and I give it the color, which is, I give it which is for each point is a number 1 to 4, and it tells it which cluster it belongs to, and it just uses the colors 1 to 4, which are black, red, green, and blue. And so these are the data, and there we see the clusters that I've imposed. So we know the clusters, but now we're going to hand these data to hierarchical clustering and not tell it what the clusters are, and it's supposed to find them automatically. And we'll use the k-means algorithm. Okay, we're going to tell it there are 4 clusters here. If we told it there were 3 clusters, it would probably find 2 of the clusters and then merge 2 of them together. Okay, so here we go. We call k-means, and we tell it 4 clusters, and we tell it to do 15 random starts. Random starts are cheap. If you remember, k-means clustering starts with a random start for where the clusters are. And of course, if you pick a bad random start, it might find you a bad solution. Unlikely in this case, but that's what we do anyway. And we can print out the result, and it prints out a number of things for you. It prints out the cluster means. There's going to be 4 of them because there are 4 clusters. The cluster vector, that's the assignment of each point to the cluster clusters that it found. And then there's some summaries of the cluster. So the within cluster sum of squares by cluster, there are 4 clusters. So that's the sum of squares within each cluster. That sum of squares deviations of each point around its cluster mean. And then, and this is perhaps a more interesting, the between sum of squares to the total sum of squares. So this is, in a sense, this is like the R squared for clustering. It's a % of variance explained by the cluster means. And that's pretty high. So it suggests it's done a good job. And then it tells us what the other components on the cluster object are. Okay, so now we're going to plot the data. And there it is. And we've identified the clusters that it found. So we plot the data with big circles for each point. And the coloring here is not our original cluster. When we generated the data, we made clusters. These are the cluster assignments found by the k-means clustering algorithm. So to see how well it did in terms of the original known clusters, we can include those points. That's why I made these circles a bit bigger. So I put the points inside. And, well, what you see now is that we have a color mismatch. So we named the clusters 1 to 4 in some order. The k-means clustering algorithm found 4 clusters and it named them 1 to 4. But of course, the ordering is arbitrary, so it picked a different order. So we can look at the clusters here and just reassign the colors, which is what I do in the next line. And now you see this is a more useful plot. So we see the outer circles are the k-means clustering cluster ID, and the inner points are our original cluster ID. And you can see the mismatches. So there's a black point, which actually belonged to this cluster from the original data, was assigned to the green cluster here. And here's a blue point that originally belonged to this cluster has been assigned to the black point. Quite reasonably, of course, because it's much closer to these as it turned out than not. So that's k-means clustering for you, and just some nice graphical techniques for having a look at the results. Especially if the data is in 2-dimensional, that's easy to do.